Okay, it's about 5 after the hour, so I think we've given enough time to let everyone get in the meeting. So welcome everyone. Good morning, good evening, good afternoon, wherever you may be. My name is Brenna Mead. I'm with International Networks at Indiana University, and this is a presentation on the GNA G APAN International Routing Working Group and the APNIC ISIF strategies for global RNA routing. And do my other speakers want to introduce themselves? Steve or Chan Kingan?
Sure. My name is Steve Wallace, and I work for Internet 2 and IU, and my work is mostly in routing security.
Hello, my name is Changqing An, and I work in Tsinghua University and CERNET. Thank you.
Thank you. Okay, so we have quite a few topics for you today. We're going to talk about international routing experiences, anomalies, and performance experienced by the routing working group. We're going to have an project update on the APNIC ISIF project by Changqing An. We're going to have a discussion about manners, our knowledge and experiences within the RNE community, a short talk about some best practice documentation we are trying to do within the routing working group, and then we'll leave time for some questions and discussion. So I'll go ahead and get started. Feel free to put any questions in the chat, or just ask as we go. Thank you. So for those of you who don't know what the International Routing Working Group is, I am the co-chair along with Warrick Mitchell and Hans Adelman. Warrick Mitchell from AARNet and Hans Adelman from Indiana University. We were established to create a community to work on international routing issues and to improve RNE performance. Our goal is to engage not only network owners and NRENs reactively to discuss and address ineffective routes, but we also want to work productively or proactively within the community to systematically create policies that prevent these issues from occurring, and also create a community for discussion of these types of issues with not only network engineers, but also network owners and anyone else who may be interested. So our goals, obviously, many of us are network engineers, so we have an engineering focus. That is to document possible anomalous or erroneous routes, identify some teams to address them within the routing working group, and then check in together as we work through them. We would also like to have a policy focus, so detailed routing policies for paths, including preferred backup paths, and verify if the policy is being followed throughout the international communities. To do this, we use a number of tools. The primary one that I use, and everyone has their own tool of choice, is NetSage. There's the link there if anyone is interested, portal.netsage.global. We also wanted to thank those of you who are with ARENAPAC for helping us get your flow and SNMP data into NetSage and adding to that world map that we're creating within the NetSage platform. Some other tools that we use: TraceRoute, Route Views, Router Proxy Looking Glass, and Perf Sonar. We're always looking for more tools and tool talks for anyone who has an interesting tool that they use or that they find useful for solving routing anomalies or dealing with any BGP or routing issues. So as I discussed, we're going to go over some of the international routing challenges we've observed in our short time. Asymmetrical routing, meaning the source to a destination takes one path and it takes a different path back. RNE data that takes a less efficient route around the world, which affects the performance. For example, Europe to Asia routes traversing the US, or Africa to Europe routes traversing the US. RNE data that takes the commodity route when the RNE path is available. New RNE links removed or added, but routing does not get adjusted appropriately. Leaking of private ASNs into the global routing table by RNE networks, and IP blocks advertised with a bogon origin ASNs within the RNE routing table. These are just a few of the challenges that we've seen in the year that this group has been in existence. I I know there's more challenges, and we hope as we continue to grow and as we continue to collaborate, these challenges will change or potentially see less of many of these issues, or at least create a community that knows how to address them with each other. So I wanted to go over a few of the cases that we've seen, that we've observed these issues. The first one we'll talk about is asymmetric routing. So we were seeing poor performance between SingAREN and REANNZ in New Zealand. And we noticed that it was asymmetrical routing that was causing the issue. So in one way, it was going SingAREN to Internet 2 to REANNZ. The other way, it was going SingAREN to APAN to TransPAC to REANNZ. We were seeing poor performance on both of these links. After working with the routing working group and changing some peering, this route actually now uses the SingAREN to GOREX to REANNZ route, improving performance dramatically and allowing us to work with those REANNZ engineers to get this problem fixed. Second example was RNE traffic using a commodity route. We saw this in a case of ITB in Indonesia to Starlight, which is in the United States. Asymmetrical routing was preventing access to the Starlight ESNet DTN. So the route from Indonesia to Chicago was using RNE networks via TANE, TransPAC, and PACWave. However, the other way, Chicago to Indonesia, was using PCCW and other commercial paths. We worked with ESNet to update the accepted routes from TransPAC to use this RNE path. Trace sets are now symmetrical, and the engineers at ITB are able to access that DTN. So that was a good one, and the team that worked on that was Peter Green from SingAREN, Basuki from Indonesia, and then myself, Brendan. Another example of routing anomalies that we saw and have solved through this routing working group, we saw internal to Asia traffic traversing the US. So Hong Kong to China traffic that we saw over our TransPAC link. What we ended up doing there was working with CSTNet and HARNET to change the peering. And traffic is no longer taking TransPAC. We're also seeing much better performance on transfers between those two institutions. So that was a successful case dealing specifically with traffic internal to Asia. Another one, this was an interesting one. Europe to Asia traversing the US. So CERN, which is in Switzerland, to KISTI in South Korea. We worked with ESNet, myself, and KISTI to fix this one. So it ended up, our solution to this one was not to make any changes, as the engineers working on this determined that the CERN to KISTI via NEAR was the correct route at this time. Upcoming this year, it may, hopefully this year, potentially into next year, the KREONET direct circuit between Amsterdam and Chicago, or the KREONET 2 direct circuit between Amsterdam and Chicago is congested. So this path is the more efficient route right now, even at 10 gig. However, this year, the KREONET 2 circuit will be upgraded to 100 gig. And we need to look back at this case. That's why we still have it, to see once that circuit is upgraded, if routing changes correctly and we see improved performance and between those two locations. The routing working group currently has 167 members on our list. We have over 20 countries represented and over 80 institutions. We have 14 cases that we've had. We have 10 solved cases and 2 cases on hold pending new links. For example, that last one that I talked about, or just lack of resources to currently work on those problems, whether it be at the NREN or the universities that we're working with. As always, as you can see, I only have 2 open cases right now, and I'm always looking for more cases and more connections within this community. So if you have any cases, any performance issues, any routing anomalies that you would like the community to take a look at, please let myself, Hans, or Warrick know, and we can open that case and hopefully get you in touch with the correct people to solve that problem. All right, we will have our project update now. I will stop sharing my screen for you.
So I think you're muted.
Sorry. Hello, everyone. My name is Changqing An, and I'm from Tsinghua University. And the CERNET, I am very happy to have the opportunity to give a presentation. My presentation is about a APNIC ISIF funding project progress. The project name is Developing a Collaborative BGP Routing, Analyzing and Diagnosing Platform. Here is the agenda. I will first present project summary information and then present the project progress on project website implementation, BGP sharing platform, looking glass platform, and analyzing and diagnosing platform and research topic. After that, we will discuss some concerns of partners and we hope get comments and suggestions from you. The project is from February 2022 to August 2023. The duration of the project is 18 months. We have 3 co-PI. They are Jinan Wang from CERNET, Shalenpo from ThaiREN, and Simon Green from SingAREN. We get $150,000 funding from APNIC Foundation and get some in-kind contribution from Tsinghua University. The objectives of the project are build a collaborative community for enhancing the capacity of NRENs network operation and management, establish a distributed BGP routing monitoring platform and a looking glass platform in the Asia-Pacific region, deploy a BGP hijacking detection and mitigation system, and analyze the robustness of routing in the Asia-Pacific region, and share knowledge and experience globally. Now we have 19 partners. There are AARNet, APAN-JP, BdREN, CERNET, DOST-ASIT ERNET, Gottingen University, HARNET, ITB, KREONET, LEARN, MYREN, NREN, PERN, REANNZ, SingAREN, Surrey University, ThaiREN, and TransPAC. The project will keep open until June 2023, and welcome to join us. We have set up a coordination committee, a technical committee, and a project executive team. This is the detailed technical committee work plan. We discussed and confirmed this work plan in May. And in May, we started BGP routing information sharing work. And in June, we started hijack detection and mitigation work. And in July, we start to discuss the research topic, and we will start looking glass platform work in August. This is the project website. You can access it at this URL. In the website, we have a brief introduction of the project, partners information, news and events, and documents. This is the architecture of our BGP routing sharing system. The collecting server uses routing FRR to simulate a real BGP router, and the border routers of partners connect with the collecting server by BGP peering. The collecting server will periodically export BGP routing information in MRT format, and it also lively advertises routing information through WebSocket. We have established a BGP session with 11 partners. They are AARNet, BdREN, CERNET, HARNET, ITB, KREONET, LEARN, MYREN, REANNZ, SingAREN, ThaiREN. And the data and configuration menu can be accessed at these two URLs. This is the website of our Looking Glass platform. Now we have connected with 6 partners, and we also do query speed limit for security. We are developing a BGP hijack detection system. It is a knowledge-based real-time BGP hijacking detection system. We call it BGP Watch for short. It is mainly based on MOS and sub-MOS events and rely on domain knowledge such as ROA, IRR, as relationship, as topology, etc. You can visit it as this URL. We have presented this work in the last APAN meeting, so we won't dive into the details. For network operators, it's helpful to monitor their network. Here, the dashboard is for this purpose. It will show information of a particular AS. First, it will show basic information, such as the AS name, the organization, and the country name. Then it will show the prefix number originated from the AS with a historical code graph. Then the distribution of the prefix length is shown as a histogram. And finally, it shows a table of the detailed prefix information. When we click a column of the histogram, the table is changed accordingly to show only the prefix of that length. For a particular AS, this picture shows the key partners of it. The blue nodes are the providers of it. The orange nodes are the peers of it. The number on the line is the prefix it export or import from the partners. This number is the prefix number it exported to this peer, and this number is the prefix number it imported from this peer. The thick line means there are a lot of prefix exchange between it and the partner, and a thin line means there are only a few prefix exchanged between it and the partner. That pie chart shows the distribution of its peers and the country region distribution. This is the IPv6 peers information. It shows the IPv6 peers information of AARNet. Usually, operator will search for the path of a prefix. For routing query of a prefix, the system will search and return routing paths of its subnetworks and supernetworks, which is valuable for operators. Also, it will group prefixes with the same routing paths, so operators can see well-organized information in the graph. When users search this prefix, there isn't exactly matched prefix, and the system returns some subnetworks of it. And the prefix with the same routing paths are shown within a color block. When we click the color block, the corresponding path will be highlighted. This is the register and subscribe interface. After subscribe, some AS users can see the brief information of them. When the prefixes originated from an AS changed, the system will show an alarm button. And click that button, user can see the detailed change information. Also, the user will receive an email alarm with detailed information. Here are some research topics we're interested in. New routing information brought by our CTTF routing information sharing platform. Is peering relationships among NREN fully utilized? And how about the resilience of the region network? This is a topic we are working at, evaluating and improving regional network robustness from S topology perspective. We have designed some algorithms and we are drafting the paper. Here are the S nodes in a region and their peering relationships. Colors and size represent cone size of the AS. Users has the option to only show nodes with higher cones. The red graph shows the resilience distribution of the region. Here are some concerns from partners. The first one is where that data is stored. Our answer is all the data is stored in clouds. BdP sharing platform is a cloud server in Singapore. And BGP Watch is a cloud server in Hong Kong. Looking Glass is a cloud server in Hong Kong. The second question is, will peering harm my network? Our answer is no. BdP sharing platform we are using our open software routing software. So it won't send a routing announcement. The third question is, will sharing route information harm my network? Our answer is that this is a common approach, and route views and REANNZ are the most famous REANNZ sharing platform. The fourth question is, our policy doesn't permit SSH or Telnet access from other networks. We have dealt with similar problems, such as SingAREN. The solution is that we use a VM to simulate a route and pair with their real route, then our looking glass access to the virtual machine. For future work, we would improve prefix hijacking detection algorithm, develop a path hijacking detection function, support user registration, and send alarm message to the victim, and continue on the research topic. This is the contact information of us. Please contact us and welcome to join us. This is all for my presentation, and we still have some little minutes, and I would like to show you the system. This is the system of BGP Watch. This is the home page. We can see some statistic information and distribution map of victim and attacker. This is the anomaly page. We can see real-time hijacking information. And the third, this is a dashboard. At this page, you can see some brief information and IP address originated from the AS and IP prefix distribution. When you click a column, the table will change accordingly. And then we can see the IPv for peers information of it. We can see the peers of it and how much prefix is exchanged with this node. This is the IPv6 peering information. we can search for other network such as AARNet. This is a routing path. We can search routing paths such as from CERNET. So when we input this prefix, we can see there isn't an exactly matched prefix, but the system will show all the subnet of it. So this is helpful to operators. And with some prefix with the same color, they have the same routing prefix. When we click it, the corresponding path will highlighted. We can input another IP address, such as there are many IP addresses in within this block. You can see that, and when we click a block, the corresponding path will be highlighted. Operators can see the routing paths of all the subnetwork. They are using their routing through different paths. For the resilience, we can see the topology and some results we have calculated. And finally, users can subscribe their and to monitor their prefix change from there. And there is, we can see a alarm button, and click the alarm button, we can see the detailed information. That's all for my presentation. Please welcome your suggestions and comments. Thank you. Any questions?
We also have time for questions at the end, if that's more comfortable with everyone here. So.
Okay, thank you.
Okay, just a moment. Okay, Steve.
Okay, so you're going to draw my slides.
Yes,
that's good. That's great. First of all, I want to say that the presentation on BGP Watch was fantastic, and that looks like a really interesting project, and it is an example of a project and effort that's complementary to Manners. So Manners is a set of behaviors that we do to improve routing security, and BGP Watch is a nice complement in terms of its ability to measure what's happening, so to observe what's happening. So anyway, I just want to say that was a fantastic presentation. I really appreciate it. So Manners is mutually agreed norms for routing security. It's a global initiative that helps reduce the most common routing threats. Manners is a project sponsored by the Internet Society, and Manners has a set of different programs. They have a program for network operators, internet exchange providers, CDN and cloud providers, and equipment vendors. And I'm going to talk about network operators. and because most of us are network operators. So for network operators, Manners recommends the following, what they call our actions. And these are briefly, and I'll talk about these more in detail, are first action is prevent propagation of incorrect routing information, prevent traffic with spoof source IP addresses. It's interesting, to be a Manners participant, you have to agree to implement actions 1, 3, and 4, but 2 is not a requirement, and I'll talk about that later, why that can be difficult or impossible for certain network providers. The third action is facilitate global operation and communications and coordination. And the fourth is facilitate routing information on global scale. And there are 2 versions of this. One is a version that uses that recommends creating records in IRRs, and the other is recommending the use of Rpki. And I have an interesting twist on this as we get to those issues. So next slide, please. So Manners action 1, what does it mean? Prevent propagation of incorrect routing information. So if you're a network operator, you must ensure that you only accept routes from your customers that are authorized by your customers to announce. In other words, these are routes that your customers either hold, or ideally, they have a letter of agency from the actual holder to announce. So in the case, and I'm going to use Internet 2 as an example in these cases. So for example, Internet 2 connects a variety of networks within the US to the research and education and global infrastructure. And when one of these typically state networks wants to add a new institution to their network, they have to submit a request to accept for Internet 2 to accept a new prefix. So Internet 2 filters prefixes it accepts from its customers. So if you need to add a new route, you need to fill out a form essentially that says this is a route that belongs to this institution and they're now authorized to use Internet 2. And Internet 2 will inspect that route and determine if that is appropriate, and then adjust our filters to allow that route to be announced and accepted into the Internet 2 network. It's interesting, in the beginning, Internet 2 did this before Manners existed, but focused mostly on the prefixes and not the origin ASNs. And Manners specifies that you need to determine that both the organization is authorized to announcing the prefixes as well as originating those prefixes from specific ASNs. This is not a static process. So if you're operating a network, it would be great if you could check these prefixes in ASNs one time when they're first requested, and adapt your filters to permit authorized prefixes in ASNs, and as long as that was a customer of your network, not consider reviewing this into the future. What we found over a long period of time is that the RIR, in our case, it's usually AARNet, usually due to some billing misinformation, may revoke typically an ASN. It's not typical for them to revoke an IP network, but that's possible. So from time to time, we will run reports on our routing table that will give us an indication that maybe we're accepting an originating ASN from our customers that is not allocated by AARNet to anyone, that's been withdrawn from that particular customer. It's usually the case, it's kind of interesting, it's usually the case that AARN has outdated billing information, and over the course of a long period of time, the institution has not received a bill for an ASN, and AARN has withdrawn that ASN. AARN has a facility called Who Was, so you can look at historical information to try and understand what's happened. So, you know, doing your due diligence, checking out whether the number of resources, including the prefix and the ASN, belong to the institution and they're authorized to use them, can change over time. And so you need to periodically review that. Next slide, please. So manners action number 2, and it's non-compulsory. And what this means is that if you want to be a manners participant, and I actually highly recommend networks consider being manners participants. So there are roughly 750 networks that are manners participants today. Many of them are research and education networks. And being a manners participant means you agree to these actions and some other terms, and you get access to an observatory that Manners maintains that lets you check on your alignment of these actions. So Manners actions number 2, not required, prevent traffic from spoof source IP addresses. So network operators should implement a system that enables the source address validation for their own infrastructure and end users, and for any single home stub customer networks. This should include anti-spoofing filter to prevent packets with an incorrect source address from entering or leaving the network. I think this language is really good. So if a network like Internet 2 connects to a stub customer network and they're not multi-homed to Internet 2, this would be relatively straightforward to implement. In the case of the Internet 2 network, we're basically a partial transit network. Many of our customers are multi-homed to us through different paths. And this is the case for many research and education backbones like Internet 2. And so this is not practical to do for many NRENs. However, it is very straightforward to do for our customer networks. So this is it's not required for Manners to do this. It's not practicable for many of the NRENs to enforce this universally across their network, but it is very straightforward for the individual university campuses to enforce this. And so part of the challenge is, while Internet 2 may not be able to enforce this, or an NREN may not be able to enforce this for their downstream customers, it is a good idea for the downstream customers to protect the internet as a whole, to ensure that their campuses can't be the source of spoofed IP packets. The risk, if a campus is not configured to prevent this, then they can easily become an amplification vector for a DDoS attack. So the reason this is a manner requirement, and this is an unusual manners requirement in that it doesn't address routing information directly. It is so it isn't part of the control plane, it's part of the data plane. it's because this is fairly critical, and this is one of the vulnerabilities we see existing in the internet, that there are too many sites where attackers can leverage a site to amplify an attack by spoofing IP addresses. So as an NREN backbone provider, you're limited in what you can do, but this is something that you can communicate to your members and help them understand why this is important, and help them understand the technical controls that they have available to them to prevent this. And at the level of the stub network, so like the university network, this is pretty straightforward to prevent. So next slide, please. So manners action number 3, facilitate global operation communications and operations. This is important. You know, the internet is made up of just over 70,000 individual networks. So there are roughly 70,000 ASNs that comprise the internet. And when you detect an issue with a network in the internet, it's important that you actually be able to contact the people responsible for that network. And if there's 70,000 across the world, then you know, one of the mechanisms you have is to use the standard means to identify who are the official contacts for a particular IP address range or a particular ASN. And so part of the manners actions is making sure that these things are up to date. So network operators should register and maintain NOC contact information for each autonomous system and net block that they are responsible for. This must include an email address, and an email address where you would expect a relatively prompt reply. In reviewing records of our members and the people that connect internet to, it's common for us to find official contacts that are registered with, more commonly with AARNet, who is services, sometimes with the internet routing registries, and probably less common with PERN-DB, is there'll be individual email addresses. So maybe there's an email address for me, Steve Wallace, ssw@internet2.edu, that's listed in these directories. And the problem is if I move to another organization, it may be the case that record is not updated. And we find that when we look at the network contacts across all the organizations that connect the internet to, it's not uncommon to see point of contact information that is old and no longer correct. So a couple of things. First of all, it's best to use a role for a point of contact where possible. So for example, rather than saying Steve Wallace at Internet 2, it's better to say NOC at internet2.edu. And that is a persistent email address that is a role, not an individual. And so that role will be persistent over time. You won't be counting on the individual. It's good to have a formal process where you review this information periodically to ensure it's correct. Next slide, please. Okay, facilitate routing information on a global scale. So this is going to, I may ignite a controversy here. Manners has two versions of this action, and they basically say you can do it with Internet Routing Registries, or you can do it with Rpki. So let's talk about Internet Routing Registries. To do this action, network operators must publicly document their intended routing announcements in the appropriate RAR registry, RADB, or RADB mirrored IRR. So what they're saying is if you operate a network, that you need to maintain information in a recognized Internet Routing Registry that describes some of your routing intentions. Now, things are changing right now. So in the case of AARNet, and I apologize for focusing on AARNet, but AARNet is the regional internet registry that affects most of our members. In the case of AARNet transitioned from a non-authenticated IRR to an authenticated IRR in the last year. And what does that mean? Many IRRs allow their members to create records for resources they don't own. What does that mean? So let me take a practical example. So Indiana University might hold the address 129.79.0.0/16. And anyone that has an account with most of the IRRs, including RADB, can create records that describe the routing policy for 129.79.0.0/16. So even if they're not Indiana University with accounts with many of the IRRs, the non-authenticated IRRs, they can record a routing policy for a network at IU. With AARNet's introduction of an authenticated IRR, and the other regional internet registries have done this as well, the AARNet IRR only allows the holder of a resource to define its routing policy. So using the AARNet authenticated IRR, only Indiana University can publish a routing policy for 129.79.0.0/16 because Indiana University holds that resource. So this is a change in progress. So in the past, there haven't been authenticated IRRs. I think in the future, information from authenticated IRRs will be considered of higher quality. The manners action doesn't require authenticated IRR. I think it's important for network operators to consider where they create their records, and looking forward, they may want to consider creating them in authenticated IRRs because that information may be considered higher quality in the future. So here's the controversial part and I think Warrick from AARNet was going to do this presentation, and he may have a different view than me. So you should hold judgment on this, but I'm going to give you one side. So Manners Action 4, there's two versions of it. One is that you create routing policies in the IRR. And the other option is that to be manners compliant, you can use RPKI ROAs instead of IRR entries to define the routing policy. So manners is basically giving you choices. You can say if you want to be manners compliant and you want to be a manners participant, you can choose to maintain records in an IRR. And they talk about IRRs generally, and I'm saying that I think there's value in creating those records in an authenticated IRR. But they're also saying instead of that, you cannot do that, and you can create records in, you can create ROAs to define the valid originating ASN for a particular prefix using RPKI, and that's equivalent. And I don't agree with that. So I think the best approach is to use IRRs to publish your routing policy and to use RPKI ROAs to further protect your prefixes from things like hijacks. I disagree with manners that one is a replacement for the other. The IRR is typically used by network operators. So you publish your routing policy, network operators read that information, and they configure their equipment to ensure that that policy is enforced. And that policy is different than ensuring, there's some overlap, but it's different than ensuring that the prefix is being originated from the proper ASN. So I think you should do both, not one or the other. So I think that may be the last slide, Brenna. Yes, okay, so some challenges with RPKI route origin validation. So to create, so roughly in the Internet 2 network, roughly 97 or 98% of the networks have IRR entries that express their routing policy, but roughly 6% have ROAs. And part of the issue with, part of the reason that's a challenge is that to create a ROA, you actually have to have an agreement with a RIR. So for most of our members, that's AARN. And it turns out that over 50% of the US research and education IP legacy resource holders they don't have an agreement with AARN. And so there's a legal agreement they have to enter into to create ROAs. And so that's a pretty significant barrier. And we're working on that to improve it. Next slide.
I think that's the end. Yeah, I think that was
that's the end. Thanks, Brenna.
Perfect. Thanks, Steve. And thank you for joining us sort of last minute. As he said, Warrick Mitchell from AARNet was supposed to give the manners talk. He was not able to be here. So thank you, Steve, for stepping in and doing that for us. It was great. And then with the last, 10 or 15 minutes of this presentation, we're just going to talk about the routing working group's goals here in the future. One of the things that we would really like to do, and is evident in this presentation today, is create a community for better resources and tool talks and presentations that people can come to and learn about things like manners or routing, or the project update we had today, or route views, or perf sonar. And so that's been one of our big pushes as we go into our second year of being here. We also have a goal, and we're looking for assistance from the community, and that's along with being part of the routing working group, is to create some community-driven BGP best practice documents. So those would be best practices for RNE network providers specifically, best practices for scalability, load balancing, RNE peering agreement best practices, and BGP communities, how to use this with a focus on RNE networking. We're creating small teams to start working on these sort of documents that will be publicly available and as resources for network engineers and NRENs and anyone throughout the RNE research community. So if anyone is interested in helping us with this task, or has good documentation already out there, or just has an interest in being part of this community and taking up this effort, do let us know, because that's where one of the things we'll be working along in the next year, along with the getting more cases to work on for routing anomalies. So these are some of the things that we've talked about at the routing working group: NetSage, Manners, router proxy looking glass, peering DB. And we always do a review of all the routing working groups, open cases and closed cases. Some upcoming meeting topics for those of you interested in joining the routing working group or are already part of the routing working group. September 20th, we will have a talk on microdep, which is yet another network monitoring network tool. October 18th will likely just be a rundown of the open cases. November 15th, we will be meeting in person at SC22 in Dallas here in the United States. In Denver, or in December, we will not be having a meeting and you all can have your holidays. So please submit your cases to me or Warrick or Hans. We are the co-chairs of this group. Join the routing working group. We'd love to have you, and we'd love for you to be part of the community. If you have an interest in presenting at the routing working group or know a topic that we should be aware of and educating the community with, do let me know so we can get you on the agenda and get you out there and into this community. We have a mailing list, a Slack instance, and a website. Feel free to contact, again, any of the chairs, myself, Hans Adelman, or Warrick. If you want to submit a case, want to do a tool talk, or just want to be part of the routing working group's community. And I believe that's it. So we have some time for questions here. And I will stop sharing my screen. Perfect. Does anyone have any questions for Steve, myself, or Changking An about the project? I have one question for you if no one else does, but I'll let you all go first.
I have a question for Steve. Do you think a provider should be responsible for its customers' bad behavior? We know some as do hijacking, and the S may be a new S, or it may change S after doing some bad behavior, and then change S to connect to other provider. So do we think we have some mechanism to deal with this problem?
So if I understand your question, I think the provider. So if I think about Internet 2 as a provider, and our members and our connector members as being customers, then I think Internet 2 has a responsibility for ensuring that the IP numbers and ASNs are that those members are authorized to announce those prefixes, so that Internet 2 has the responsibility to ensure towards its customers that those are valid. So for example, if customer of Internet 2 started announcing a new prefix with an ASN that wasn't theirs, that we would be responsible for filtering it. So does that answer your question?
Thank you. Thank you.
I do have a question. You said that the project is an 18-month project, and it's a very interesting project. And I was wondering if there are plans for after that, those 18 months for the project or the platform that you've created. Are there any plans for after the project is over?
I think this is our research interest. Our team, the main research focus on the routing, hijacking, and route leaking. We will continue on this search direction. Thank you. And I have a question. We haven't deployed Rpki, and our operators, they have some concerns. Maybe that maybe after I deployed Rpki, maybe my routing path may be affected, maybe changed, and we have some tools to monitor the path changing. And another question that is, if I register my prefix and I don't deploy the Rpki on my router, is this okay for us?
So that's a really that's a good question, and something we're currently dealing with Internet 2. So there are two pieces. At least I think of two pieces to Rpki. One is creating a ROA to protect your prefix. So if you hold IP space using your regional internet registry, for most of our customers, it's AARNet, to create a ROA. So that provides some protection from route hijacking for your prefix. The other component of that is, if you're operating a network, is doing Rpki route origin validation. Internet 2 is not currently doing route origin validation. And we're working through a process, engaging our community, hopefully getting to a place where we'll be able to do that, but there are concerns. So for example, one of the Internet 2 services, we call it I2PX, and allows Internet 2 users to get to much of the commercial internet, the cloud providers and other parts of the commercial internet. Many of the routes on the order of hundreds to maybe a couple thousand, if we did route origin validation, we would delete those routes, and those routes would not be available to our users, at least through that service. And in many cases, these are errors in creating the ROAs. So in other words, organizations have unintentionally created Rpki ROAs, which would cause their routes to be deleted by much of the internet. So we're currently in a process. We would like to find a path to do route origin validation before the end of the year. But we do see these as two separate things. So we are working with our members and promoting the creation of ROAs, and we are taking a deliberate process to using Rpki information to do route origin validation, and that's a careful process. hopefully that answers your question.
Thank you. Thank you. I think the Internet Society should have some support for the AS operators to promote them to deploy the Rpki. Thank you.
Okay, are there any more questions in the audience? We have plenty of time. We have about 10 more minutes. All right. Well, if you have questions later, feel free to reach out to any of us. I'm sure we are willing to answer any questions you may come up with later. I wanted to thank all of our speakers. Thank you, Steve. Thank you, Changking An. I really enjoyed both your presentations, and thank you as always for participating with the routing work.
Thanks, Brenna.
Well, rest of your APN. Oh, yes, David.
No, I was just saying thank you. That was great.
Oh, yeah. Well, thank you, everyone. We'll see you at APAN 55.
Thanks a lot, Brenna.
Thank you.
Thank you.
Thank you. Thank you.
Thank you.
Thank you, everyone.
Bye-bye.